they do that at level 2s. Going from level 2 to level 3 is where they'll be removed. So people who want the aurora can look at the level 2 data, and people who don't want the aurora can look at the level 3 data. And also remember, because of the trefoil, whoever's looking over the pole and is contaminated by aurora, if it's a contamination, the other one's over here, and the aurora's not in the field of view, so that works to our advantage too.
Well, knowing aurora a little bit, I would say it's very complex. It's not as nearly as simple to remove as the stars. It has those mesoscales on it. It does. So it's gonna be a problem.
Believe me, we're losing sleep over it. So it'll be okay.
So I have a question about the simulation that you have for the aurora. What are you doing that is bright?
That is right.
What is bright? Yes, are these electrons? Are these
No, there are two types. So the one that I call aurora are precipitating electrons, and they correlate with field line current that's anti-parallel that's going up.
And you know the solar mass ejection emitter aurora that we're seeing, that we're extended out to 10,000 kilometers, and along the magnetic field present.
Yes, that's the paper that Craig introduced us.
Could I ask each questioner to identify themselves for the sake of our remote, and for people who don't know you?
This is Marcus here, and this is for Steve. So this urban surface is also very much dependent on the phase of the solar cycle. So I think we have not discussed too much about, but the latitudinal, shape of the overall structure is going to be very different. So I want Steve to really highlight, what is the plan for doing this. The other probably for Craig, that we are launching it the maximum phase. I think PUNCH really demands a extended cycle, extended phase, because unless we run all the way up to minima, this entire mission, the overall thing will be really, really incomplete. So I think on the day one, we should look for an extended mission up to the minimum at least.
I agree. Yeah, definitely. We want to sample as many phases of the solar cycle as we can. I think at the STSW meeting last week, I saw from somebody in the seismology that the rush to the poles of new polarity with the new formation of polar coronal poles is sort of now underway. So yes, we can start to see these evolving phases. Fingers crossed.
One question for one from Colorado Space Flight Center. One is for review. So you measure the most of speed in night sky. So how about the project?
I want to ask the questioners to identify themselves, and they're not doing it, so.
So first of all, you should really move away from the concept of plane of sky, because eventually of view, that's not a plane anymore. So there's going to be an extra step for relating what we see in the flow fields to the physics, the meaningful interpretation of those velocities. It will not be like your usual coronagraph data. So there were a talk earlier, I think it was from Sam or Chris, who described that. So I really invite you first to look at those talks again to understand the geometry effect, and then you can revisit that question. That's best. I don't want to insert too much there.
Second question for the sun. So you correct the star very good. But how about the planet? Planets can be for such large field views, high chance to be in this field view. How to correct this?
Yeah, there will definitely be planets that we see a lot. They do not move like stars. The field of view, they're not a fixed that coordinate, so they are not picked up at all by the star field subtraction. I don't believe the SOC has any plans right now for removing the planets. That would be really hard. Those pixels, so we can't just subtract them out. And we can definitely provide sample code for identifying where the planets do appear. And then if you want them mapped out in some way, then you're able to do that yourself by knowing where they are.
Please identify yourself. There are other people watching.
I'd like to remind the guys at the table, you want the mic on red when you're not talking, otherwise we get feedback. Let's see, this really is a request for a little bit more amplification. I had the delightful experience of having my intuition broken today, just now. We all know there are subalpinic wind regions behind some CMEs. I've always thought of those as islands. Do you really think that that's a finger of corona coming all the way out?
Yes, and the reason is because MMS look at the electron distributions and we see straw electrons. It's connected all the way to the core.
That's exciting. We have a lot to do.
Yes, well, if those are electrons, then when they're in the shade, you should not see them, right? You won't see Thompson scatters.
It's really hard when you're remote, when they're just not telling you who they are.
The straw electrons are from the sun. They are distinct. I mean, they can participate in the aurora as well, but they're distinct from the kind of electrons precipitate to cause the aurora.
Okay, but then how are they, why are they shining?
They're not.
Okay.
But those are
Then why would you see them? You won't.
Hello, I'm Vagilia Samara from Goddard Space Flight Center. We had discussed with Rafael and Nikki in the past that one of the milestones of the PUNCH mission is to provide some velocity maps to drive models, which is something that I find fascinating, but it's still not clear to me how this is going to, not how, but like the format of this data, because if you work with 3D imagery models, you need to give specific, for example, boundary conditions at point one EU to drive them. Either, for example, this is with the WSA model or this is with IPS data. You need to give some velocities, for example, in latitude, longitude format maps. So is this something similar that's going to happen with velocities, or we should adapt the models somehow to prepare for that?
Yeah, there are three mini components to your question. First one relates to the earlier question we had regarding, what happens for, regarding the fact that their feet really can be, more or less, towards you. And what is that going to do for the interpretation of the 3D volumetric interpretation of the flow field? Because again, I'm only giving you a 2D flow map. So there is with the polarization signal and other theory involved on how to use that polarization signal. My understanding is that there will be an ability to automate the 3D localization of what you're actually tracking. So what I suspect is that between what you want to do and what we provide, we will have to meet each other halfway. So I do believe you will have to adapt somehow your simulation to be able to make use of our output. Keep in mind also that what the SoC provide won't be at all this 3D localization of whatever our tracking is doing. But I'm happy to help there whenever I can to provide this sort of augmented data product with an augmented velocity flow map product that is more 3D aware.
Okay, so there's need to be a lot of discussion and collaboration between the observation people and the modelers to make that happen, right? It's not straightforward. I just wanted to make sure it's not straightforward and I'm missing it, or it's more work that needs to be done.
So yeah, anything that is not within the science goals of the of a working group. That will not be straightforward. It will require a more collaboration, maybe funding to make that happen, at least from my end. So keep in mind what are our priorities. If you want to kind in and use what we do to satisfy our same goals, then that would be straightforward because we're here to work delivering them.
But let me say also, there is maybe a simple version, which is, let's say we have these flow derived maps and Raphael's flows say, there's a fast stream that's coming out this way. And you look at your model and you say, there is no coronal hole there. I don't know how there could possibly be a fast stream there. Already that's a new test, a new constraint on the models. And so I think there's some basic things that we can do before we do the more complex three-dimensional mapping.
Also, this is sort of a similar situation as, you know, when the people who do solar magnetograms, as the lower boundary condition for models, they provide those central meridians that eventually over a solar rotation have to be built up into a synoptic. This could also be used over sort of stable rotations as plane of sky maps that could then be built up into a synoptic over some solar rotation.
Thank you very much.
Hi, this is Yan Yang from Delaware. Just as a follow-up question about the velocity. I know the density field is the primary field that the punch can provide. But in Raphael's talk and in the flow tracking map, you can also maybe provide the velocity field. Just the question is, the velocity field that you can provide, how that field is different from, let's say, the particle log flow velocity field.
The ball tracking method that Raphael does, that's not going to be the standard product. That will catch the little, you know, the little sideways motions and the little ones that are a little bit different, and so that you can really look at the details of the flow field for the interpretation, which is different than the global flow maps that he's providing.
Okay. Then the other question is to Nikki. So I remember when we, in our previous paper, we compute a spectrum of density field. And the question that we encountered before as the density field actually is integrated along the line of sight. So the density field that we can get is neither 3D nor 2D. And then in terms of the mesoscale structures, right? If you use those integrated density field to try to identify, let's say, mesoscale structures, then how that integrated density field can affect the identification of mesoscale structures?
Yeah, well, you know this, right? The closer to the sun you are, the easier it is because you have less of a line of sight integration. But yes, it gets complicated as you go further out because you're integrated over more and more stuff. On the other hand, the structures also kind of get bigger, so maybe the two effects can be okay. But as you guys showed, you actually, spectral slopes don't work. You can't really interpret them well. You have to go to structure functions. And so I'm so glad we did the forward model to really know that our but this more complex.
You guys can kind of hold it a little to the side of your mouth so that, yeah. Thanks.
Yeah, and then a question to you, Steve. So if we want to identify, like, let's say the aphanic zone, right? You need to compute the alpha speed. To compute that, you also need to make use of density field. And the density field that the punch can give us actually is the integrated density field. Then that's going to affect the definition of computation of the calculation of the alpha speed, right? Then maybe it's going to affect the accuracy of the identification at the authentic zone.
Sure, yeah, no, and in fact, I think the default way of going about this from the observations will even go in reverse. Because if we can measure the speed of structures at the authentic surface, and then we know something about the density, that will allow us to back up the magnetic field strength. And the speed is just coming from these kinematic, structures in the density field that are moving along like leaves in the wind.
Thank you.
I did have a sort of a follow-up question about that. We had talked.
Well, but actually, they were awesome questions. The question, I mean, we are, after all, limited by the kind of observations we can do. It's not a choice. It is kind of what's been imposed by nature. So my question was, how do we go beyond this? How can something like the tools of AI advance some of these questions? Because there are all kinds of mathematical functions that are coming up where we are able to do 3D representation from 2D ecliptic maps, or various manners of stuff. So I wonder whether that might assist us in kind of, if there's rapid data taking, some of those tools could be applied to pull out some of the information, including the flow tracking and all of that. So my question to all of you is, how are you hoping to utilize the tools and techniques of AI?
Thanks, Nika, for bringing the AI questions, and I'm sure Craig. So actually, I had a conversation earlier about utilizing the historical knowledge of what CMEs are, what CARs are, so that we can create. We first need to create labeled data sets. That would be a good step. Validating that we can also identify them sort of manually or semi-automatically in the PUNCH dataset. Once we have that, then it opens up a series of interesting AI applications, such as, what AI is really good at is to transform, to go from a high dimensional space to a low dimensional space, and reconstruct that to do classification or forecasting. And so that definitely what PUNCH will provide, either the flow track or the imagery itself, the combination of that will absolutely be very useful and very interesting to input into all sorts of neural nets to do forecasting, semantic segmentation, classification, of different classes of heliospheric structures and heliospheric events.
I have two questions. One of them is a very simple problem. Another one is probably an open question. So the simple one is, I understand that this standard velocity data product that will be included on SOC is based on the correlation tracking. So how has the correlation tracking process been validated? Did you guys use any artificial data sets? Just how to be sure and the information about expected uncertainties?
Sure. So I got a slide on that. First, actually, before deciding we would go with the correlation tracking at the SOC, I was actually first evaluating the performance of the ball tracking method applied. Remember that part? And in that process, I had already created manually tracked features, manually tracked data sets where I had basically ground truth on what was the velocity of the density structures. So that data set also was used with the correlation. So in the end, ball tracking was sort of already itself proven to provide that ground truth with respect to the manually tracked data. And on top of it, then we adapted the correlation tracking, and the comparison of ball tracking and correlation tracking is giving us already these additional error bars. And I showed earlier that once you correct for systematic linear error, then we are in agreement. So the very first known, ground truth that we used was, sort of validating that.
So, and did this ground truth sort of synthetic data set didn't include the radios?
They were not synthetic, they were cartoon data, they were real data.
Yeah, what?
They were manually tracked density structures in the core two observations.
Okay.
So they were real structures. Finally, the second step is still ongoing. I am using your flow tracking challenge to continue validating that. So the paper that characterizes the method is not out yet. It's going to be probably in 2-3 days right before launch. And where I will put also the outcome of the flow tracking challenge for both correlation tracking and ball tracking. And so you will have
I think it will be interesting.
Yep, absolutely. And we are also working on MHD simulations where we would have another physical ground truth on those velocity, and we can compare that. That will come at a later time, probably during the instrument commissioning phase.
And my second question was probably for Nikki Bell. I'm really wondering, so the question that you guys asked about, like, are we planning to use AI or machine learning and so on and so forth? My question is like, what do you think about the most interesting unresolved physical problems in this mesoscale solar wind corona coupling problem, which could be addressed using artificial intelligence? Something that we could not address otherwise with the existing ones. I really want, and it's just a very general question. Instead of just doing something a little bit better than before, is the fundamentally unresolved problem where we have much better chance to get an answer if we use AI.
So, first of all, I have to say, we do not require AI to reach closure on any of our science questions. But, of course, the whole purpose of this week is what can we do beyond closure? And I think one of the places that AI really can help is the connectivity between punch. Okay. I think the connectivity to lower down, I think is, Punch's inner field of view is 6 solar radii. So to connect with all of the data that is being taken in the low corona and middle corona, I think AI could really help with some of that.
But cause and effect links.
Comment on the team. I think now there is a frenzy for new classes of AI, which are the physics informed neural nets. Yeah. So the so-called PINs, physical informed neural nets. So all the lots of the inversions that are that will be done, that will happen. You should keep an eye open on how you can import that into a PIN. Because in those PINs, your loss function now is completely rewired with the physical equation themselves. So they become PDUs, very efficient PDUs that can be much solving things much faster with enough accuracy to answer a problem that is otherwise answered with much more computation constraints.
So I feel like we're putting Raphael on the spot a lot of times here because of ball tracking. I mean, let me just say, I love looking at those pictures of the ball tracking. They remind me of the Matrix, where the numbers are going up and down. I think it's just hypnotic, I think. And one of the things I was wondering, just staring at them, gazing at those pictures, it seems like the brightest features that you see are moving at different speeds from the ones that appear to be in the background. I guess this is something that you've looked at. Is this an effect of the trigonometric effect, because things deeper are traveling at a different angle? Is that a dominant effect?
I believe so. I believe that you have different features that are not in a single. They are all not different, all in a single plane. There are different. There is some depth there.
So if there's, maybe there's some scope there for Vika's AI or something.
Absolutely. So
try to pull out different string tubes or something.
I don't like to systematically jump into AI. As
maybe just a smart postdoc can do the same thing.
There are all the things that I consider there are Kalman filters that do not really require AI to help with determining disambiguate these effects of, geometrical effect. The spherical tracers, the spheres in ball tracking, they have momentum, right? And so they can actually already compensate for, say, if you have a density structure that is actually not completely radial, that's sort of going off that real direction, then you may actually lose visibility and or regain it later, thanks to the momentum of the ball. They have inertia, and we have enough control parameters to control that amount of inertia. And this way they can actually sort of catch up on, say, disappearance due to some weird overlaps between structures. They can also, and that's a sophistication I got from the Nike ball tracking, really the one that I readapted to PUNCH, which is the ability to track coalescence of structures and clustering. Both structures that appear to be merging, structures getting to be clustering, and that could happen also because simply in optical thin plasma you get structures that are crossing each other but not actually colliding each other. And ball tracking can actually be something and track all of these effects.
Great stuff, thanks.
Did you also invert the images and refit them with balls that way?
Invert the images.
So the dark features become bright features?
Well, and colors is very arbitrary, but yes, a brightness enhancement in ball tracking is actually converted into, a dip, and the balls, they settle down in there and they track out.
Rafael is on fire, so. Again, a question to, so traditionally, the fast wind, or the fast CME and the slow CME has been defined with reference to the background solar wind. So for the sort of, kinematic studies of that and the statistical arrival time information, so this kind of exercise, what are you able to, really distinguish between in your simulated data or the core data, whatever you have used to identify the CME speed with reference to your background solar wind?
Yeah.
Because that will be very, very useful. And then once the lot of data is available, because AI could be also quite useful to identify the structures and the CME arrival time information.
Yes, so that, I'm going to repeat a little bit the question earlier that, yes, using that, we can maybe create labeled data sets and have CNNs, not the medium, the convolutional neural network.
But whatever data you have utilized, can you clearly, sort of differentiate between?
We have one great case study, and there's a poster about it from the IMIA and Heather and me, with a paper published January 2025 with a clear detection and tracking of a CME that is rather slow CME, but that is very well detached from the ambient wind, and we are tracking both of them with ball tracking and able to distinguish them in the same fluid fields, by simply with a careful analysis of the ball tracking output, which is not something we can do with the correlation.
This will be really useful.
Elena from Gil, Rafael, I have questions for you. I have a question for Steven. You showed the tool to generate synthetic punch images. So what was the input? Was it some predefined three-dimensional density distribution?
The three-dimensional density distribution was essentially reconstructed from a photosphere magnetogram, where we used results of 1D solar wind models to figure out what should the density be from 5 to infinity solar radii. So basically we wanted to be able to tweak every little flux tube, every little place with an algorithm that we control, and then so that we can easily pull out the ground truth.
Okay, and second question, is it possible to apply this tool to density distribution from each models?
Sure. Yeah, let's talk. Yeah.
Steve, about the updated component, so
Since now we are sort of maximum, is it possible to prove in the process of the existence of multiple atmospheric sheets instead of
Sheets are sort of orthogonal to the boundaries.
because in the atmospheric sheets, the wind is not up there.
Right,
Can
right.
we can prove
Yeah, in those cartoons that we showed from some of the simulations, the place where the outlet surface comes way in close to the sun is usually around the atmospheric current sheet. Oh, yeah, no, I don't know. Hopefully if we can get good latitudinal, dependence for specific punch times, then we know from extrapolations that where we think the current sheet is, and we see correlations with the, punch derived, alpha surface, that will really help, rule out certain ideas or confirm other ideas. Yeah.
So last question. That would be you, Russ.
A correction, I think, this is Russ Howard from APL now. Correction to Raphael's interpretation that, I think that the horizontal line in your plots is the same impact parameter at every point. And so the structures that are going slower have to be on rays that are going further or away from the plane. And so in fact, they're further out, not closer in.
Yeah, no, okay, maybe we haven't spoken, but yeah, I agree.
Okay.
All right, that concludes our session. I believe, yay, right.